Hello, students. We are live. If there is anybody in the chat section, please let me know. Am I audible? Just give me a quick thumbs up in the chat section if everything is fine with my stream. Okay, I think everything is fine. If you face any kind of issue, any kind of problem in my live stream, just let me know in the chat section. So, hello students, this is Sakshi Singhal and I am a mentor at Geeks for Geeks. And from this video onwards, we are going to start probability and statistics, which is a major topic in your GATE data science exam. Right, so we are going to cover each of the topic. We are going to cover each topic in depth, and also we are going to work on the questions based on that. So, in this video, we are first going to work on the syllabus, that what is the syllabus, and I have divided that syllabus in the section. So we are going to discuss about that, and then we are going to move to the first topic, which is in probability and statistics. And we'll have sessions on Wednesday, Thursday, and Friday. Thursday, Friday, and Saturday on YouTube, in which we are going to cover all the topics from probability and statistics. Okay, so guys, be there, and we'll make sure that no questions left unsolved by us in exam, right? When we'll prepare like that. Okay, so yeah, let's go through the syllabus. Or should I wait for 1 or 2 minutes so that more students will gather? Okay, let's just wait for 1 or 2 minutes and tell them you can share it with your friends or your colleagues so that they would also take benefit from these lectures. And guys, at any point of time, if you face any kind of doubt, you can post that in the chat section. Okay, so yeah. Okay, so if you will see the syllabus of probability and statistics, you will find out that these are the topics which are there. First is counting, permutation, and combination. This is the first topic. And if I'll talk about the computer science students, this topic they have studied in combinatorics, right? They have studied some more topics like inclusion, exclusion, generating function, and binomial theorem, all these things, but it is not required here. Then, so we are going to discuss counting, permutation, and combination in this video. Then we have probability, axiom, sample space, events, independent event, mutually exclusive events. So that means definition of probability and types of events get covered in the second topic. So that's why I have divided it in topics, right? So that's how I have divided it in topics. So this is my second topic. Third topic is marginal, conditional, and joint probability. So in this, first you have to understand joint probability function, then we'll work on marginal and how to find out conditional probability. We are going to work on that. And this Bayes theorem is basically help us to solve the probabilities for conditional, help us to find out conditional probability, right? So this is a theorem which will help us to find out conditional probability. This is another topic. Then we have to work on expectation and variance, and we have to specifically work on conditional expectation, right? So we are going to discuss that. We'll discuss that further. Next is mean, median, mode, and standard deviation. These are some statistics topic: mean, median, mode, and standard deviation. So we'll discuss that. Then we have the next topic is correlation and covariance. I have taken these two in two different topics because I'm going to cover these two topics in individual classes, right? Next is random variable, discrete random variable, probability mass function. So if I'll talk about computer science students or any student who have studied mathematics or basic probability, they have studied random variable, discrete random variable, continuous random variable, and types of distribution, right? So we are going to discuss all of that in this section, which is we have this discrete variables, which is binomial, Bernoulli, continuous. In continuous we have uniform, exponential, Poisson, normal, standard, normal, t, chi-square, right? All these functions we have. Next is conditional probability density function, right? This is different thing. And next we have some statistics topic, which is central limit theorem, confidence interval, z test, t test, and chi-square test, right? So we are going to cover all of these topics in these YouTube sessions, so that you would be prepared for probability and statistics. And guys, one thing I just I have to make sure, I'll make sure to you that if you will study all the topics here, then you do not have to go for another books, right? So we are going to cover in depth all these topics. Okay, so let's start with this first counting topic. Should we start, guys? Just give me a quick thumbs up in the chat section if everything is fine till now. If you have any questions regarding the syllabus of probability, just let me know in the chat section. So there is no question, so let's move forward. Okay, so first is permutation. So guys, the first thing students have a difficulty is the difference between permutation and combination. So we'll first understand what is permutation. A permutation is act of arranging the objects or numbers in order. So that means if I'll arrange number of objects, then we'll say that it is a permutation, right? So if I'll arrange the objects, this is permutation. And the formula for permutation is NPR, n factorial upon n minus r factorial, right? So it's basically act of arranging. And how many different signals can be made by 5 flags from 8 flags of different colors? So that means we have, you can see that we have to arrange these colors, right? Different signals can be made from by 5 flags from 8 flags of different colors. So this is an example of permutation. So how can you make 5 signals out of 8? How can you make how many number of different signals can you make out of 8 flags if one signal can be formed using 5 flags? So any idea, guys? Just let me know if there is any idea for this question. How would you find out the permutation? Permutation is an act of arranging the object. So you can see that we have to form a signal, and in signals we have order matters, right? Order matters. If I'll take let's say if I have some colors, red, blue, green, and we have then yellow, and then we have orange. If we have these colors, so you can see that if you will if I talk about one flag, this is one flag, and if I have to make another flag, can I, if I interchange any two colors, then I get another flag. So here order matters. If I'll take red in place of blue, then order gets differentiated, we will get a different flag. So that's why this is a permutation, and permutation is an act of arranging the objects or numbers in order, and in this order matters. In permutation, order matters. So when you are thinking that you have to arrange some colors or something like that, if you are arranging and in which order matters, then you will say that you have to use permutation. Otherwise you don't have to use permutation. Let's say if I have to pick 5 balls from a bag, in which we have 8 color balls, then there is no order matters, right? I have to pick 5 balls and then I'll count all the colors. So here order does not matter, so that would not be a permutation. In permutation we have order matter, so that's why we have talked about different signals. Okay, so now because order matters, so it will become 8p5, and we know the formula in factorial upon 8 minus 5 factorial. So it will become 8 factorial upon 5 factorial, and it will become 8 into 7 into 6 into 5 factorial, and this is 5 factorial. It will get cancelled, and on solving you will get your answer. So right, any confusion in permutation? Right, where order matters we call that as a permutation, right? And where order does not matter, you will see that that would be combination. Let's see. Combination are way of selecting the objects. देखो, in permutation we have discussed that it is arranging the objects because their order matters. So that's why we are arranging. Like I am putting red color before blue color, like these. I am arranging the numbers. I am arranging the colors. All these things. But here we are selecting. That means I have to select 5 balls out of 8 balls. Right? That is selecting. That would become combination. Or number from a group of objects or collection in such a way that order of the object does not matter. So you can see here that we have written order of the object does not matter in combination. So by studying the question, you have to understand that here order matters or here order does not matters. If order matters, then I'll go for the permutation formula. If order does not matter, I'll go for the combination formula. Always students has this doubt that how to check that either I'm going to use permutation or combination. So these kinds of questions, right? I hope after this lecture you do not have this issue. And you can see that formula for combination is n factorial upon r factorial into n minus r factorial. So you can see that in permutation we have npr, and the formula was n factorial upon n minus r factorial. So you can see that we have added r factorial in combination in denominator. So that's why because let's say if I have 5 colors, I am arranging those colors in permutation. So I am going to count these 5 factorial, right? Because I can arrange these 5 colors as well: red, blue, green, yellow, orange. Then I can take blue, green, yellow, orange, red, right? These type of combination, these how many combination we'll get? These 5 factorial. So that's why I am dividing it with r factorial. For this combination formula we have n factorial upon r factorial into n minus r factorial, right? So that is the formula for combination. Now let's see this question: how many poker hands of 5 cards dealt from a standard deck of 52 cards? So you can see that we just have to pick 5 cards out of 52 cards. How many poker hands, right? We have to pick 5 cards out of 52 cards. There is nothing like first I have to pick this card, second I have to pick this card. There is nothing like that. So it's not arranging, it's selecting. Here order does not matter. So I can directly write down 52 C5, and using this formula I can solve this question. So I hope this is clear to everybody that how to solve combination. Let me know guys if there is any question, any confusion. Okay, so yeah, let's move forward. Now we have counting principles. There are two basic counting principles: sum rule and product rule. Sum rule says that if a task can be done in n1 ways and or n of one of n2 ways, none of the set of n1 ways is same as none of the set any of the sets of n2 ways, then there are n1 plus n2 ways to do this task, right? Let's understand this with the question. So you can see that in this example, number of ways to order a dish from 5 veg dishes and 6 non-veg dishes. So I have to order one dishes. I have 5 veg dishes and 6 non-veg dishes. So how many ways I can do this? I can pick 5 veg dishes. So I have 5 options for veg dishes. For non-veg dishes, I have 6 options. So how many ways I have? 5 plus 6. So that is your sum rule. I can add all those options I have and we'll get the number of ways, right? Similarly, we have this product rule as well. If a task can be broken down into a sequence of k subtasks where each subtask can be performed in n1, n2, nk respectively, then the total number of ways the task can be performed is product of all those n1, n2, nk, right? So let's say if I have to I have to pick some balls, right? Let's say I have a bag, and in this bag I have 10 balls. So I have to pick these if out of this bag I have to pick first 2 balls and then I have to pick 3 balls, right? So what how many ways I have, right? So how would I do? First I'll pick 2 balls, then I'll pick 3 balls, right? So that means for these 2 balls I have how many options? 10 options. For the first 2 balls let's say I have to pick first two balls, then I have 10. If I have to pick two balls, so for first ball I have 10 option, for the second ball I have 9 options. So that means I have taken the product, because I have picked one ball, so I'm left with 9 balls, so I have to pick second ball from the 9 balls, right? So the example was that if I have to pick two balls out of these 10 bags, right, I cannot pick directly two balls. So that means first I have to pick one ball, and then I have to pick another ball. So I have divided it into two tasks, so two subtasks. So for the first subtask I have 10 options, so that's why I have written down here 10, because now I have taken one ball from the bag. So that means in the bag we have only 9 balls left, but again I have to pick one ball. So if I'll pick one ball from the 9 bags, so for the second ball I have 9 options, so 10 into 9 will become 90, right? So I hope this is clear, that how to use product rule. Let's take one more example for this. In how many ways a person choose a project from the list of project of sizes 10, 15 and 19? So that means person has options, uh, that he can choose projects from first 10 projects, from the second 15 projects, and from the third 19 projects, right? So he has to choose from these three list of projects. The person has a choose or choice of choosing a project from either of the three list. Like this is, you can see that he has to choose one of the project out of these 10, 15 and 19. So that means these are n1, n2 and n3 tasks, and you can use some rule, right? Because he can choose from the 10 option or the 15 option or the 19 option, like we have taken in the veg and non-veg example, right? So total number of ways will be 10 plus 15 plus 19. That would give you total number of total number of projects, total number of ways he can choose he can choose a project, right? Let's take another example. In how many ways can three winning prizes be given to the top three players in a game played by 12 players? So again, because you have three positions, and you have to give 12, you have 12 players. So how many ways for the for for winning three prizes be given to these players? So for the first prize we have 12 options. For the second prize, if I'll divide it in subtask, first I have to give first prize, then I have to give second prize, then I have to give third prize. For the first prize I have 12 option. For the second prize, because I have given one prize to the first one, so that means we do not have 12 players now, we have 11 players, because the person we have given the first prize, we can't give that person second prize, right? So for the first person we have 12 players option. For the second prize we have 11 players option, and for the third prize we have 10 players option, right? So how many players now? Because it gets divided into three subtasks, n1, n2 and 3, so it gets multiplied. 12 into 11 into 10 will give me number of ways to uh, give three winning prizes uh, to top 12 players, to 12 players. Okay, so that's how you will find out this total number of ways. So now you understand, if you have given options, then you will add those options to find out one project or one dish, like that. If you have to divide it into subtask, and then you have to find out find out the number of ways, then you will use the product rule. I hope this is clear to everybody. Just let me know if there is any confusion. Okay, so next we have is another question. Just try it by yourself. You can see that how many distinct license plates are possible in the given format. Two alphabets in uppercase, followed by two digits, then a hyphen, finally four digits, like sample like this. So that means two we have alphabets, then two we have numbers, and then we have four numbers, and between them we have a hyphen. So you can see here, like when we are talking about players, when we have given first position, we have 12 players option for the first position. For the second position we have 11 players option. But here it is not mentioned that we can't repeat letters, we can't repeat letters. So that means if A is for the first place, for the first, let's say 1 2 3 4, and then hyphen 1 2 3 4, these two will be letters. Because these two will be letters, so how many letters we have in English alphabet? We have 26 letters. So for first position we have 26, and for the second position we have 26 as well, because I can use similar letters on both the position, right? Because it doesn't say that the word, the letter which you have used on the first position, you can't use that word on the second position, because I can use that word again and again. So that's why we have equal chances for each of the position, right? Next is we have to give numbers. Again, for the numbers, we have, if I'll count all the numbers 0 to 9, we have 10 numbers. So for each of the position, we have this position as 10 possibilities, 10, 10, 10, 10, 10, and one more 10 here. So we'll get the total number of possibilities, this. I hope this is clear to everybody. Just let me know, guys, if there is any confusion at all. Okay, so let's move forward. Next is pigeonhole principle. So what is pigeonhole principle? Pigeonhole principle says that, let's take understand with example. Suppose we have 20 pigeonholes, right? Sorry, we have 20 pigeons and 19 pigeonholes. If I'll try to fit one pigeon in each of the pigeonholes, right? We have 19 pigeonholes, we have 20 pigeons. If I'll try to all fit all those pigeons into those pigeonholes, if I'll give each pigeon uh, individually each pigeonhole, right? One hole for one pigeon, but we are left with two pigeon and one pigeonhole at the end. So what will we do? We'll put two pigeons in that pigeonhole. So it's a general principle says that uh, if there are more pigeons than pigeonholes, then there must be at least one pigeon with at least two pigeons in it, right? At least one of these 19 pigeonholes must have at least two pigeons in it. So this is a simple case, right? Let's say if you have five chocolates and you have to give to four children. Let's take a simple case. So if you have to provide five chocolates to four children, then either you will give one to each of them, you are left with remaining one. So what you can do, you can give this one to any of the student, any of the children left, right? So at least one of the children has more than one chocolate, has at least two chocolates. So that what pigeonhole principle says. So you will say that this is a basic concept, why we have given a name for this, right? Why we have given a name? Let's see in questions, right, how we are going to use it, and why is it so important that we are discussing this basic concept as a pigeonhole principle. Right, so let's see this question. How many students must be in a class to guarantee that at least two students receive the same score on final exam if the exam is graded on a scale of 100 points? Guys, these type of questions also gets asked in interviews, right? Because these are completely depend on basic concepts and basic common sense. So in mathematics we have given this common sense a name, that is pigeonhole principle, right? Yeah. So the question is that how many students must be in a class to guarantee that at least two students receive the same score on a final exam if the exam is graded on a scale from 0 to 100 points. So exam is graded from 0 to 100 points. So any students can get marks from 0, 1, 2, 3 up to 100. So anyone have any idea that uh, how many students would at least, there is how many minimum students should be there so that at least one of the students get at least, so how, so that at least two students get the same marks? How would we find out that? Any idea? Just try this once, guys. See, because we have how many options? One student can get 0 marks, one student can get 1 marks, one student get 2 marks, one student get 3 marks, right? So if I'll give different marks to each of the student, Then how many students I have? I have 101 students. If I'll have 101 students, then I cannot guarantee that at least one students get 2 marks, because there may be a chances that from 0 to 100 each of the students get 0, 1, 2, 3, 4 respectively, right? If each student is getting different marks, but if I'll add one more student here, because each of the students have 0 to 100 marks, if I'll add one more students, then this students can only take marks out of this. So because each student already has the same marks, if I'll add one more student, then that students have the same marks as one student which we have already written down. So that means 102 students makes that possible, that at least two students get the same marks, right? What we have done, we have taken the worst case, that every student is getting different marks, nobody has is getting the same marks. So we'll get 101 students, we'll get the worst case that only 101 students get the same different marks. But when I add one more students, then I have at least two students who have the same marks in each of the case. Let me know if there is any confusion, because next question you are going to solve based on that completely. Pigeonhole principle. So right, pigeonhole principle says the same, right? 19 pigeons, 19 pigeonholes, 20 pigeons. So at least one of the pigeon has at least two pigeons. One of the pigeonhole has at least two pigeons. Here the same. Pigeonholes are the students and the scores, the numbers are pigeons. Sorry, these are the pigeonholes, the numbers are the pigeonholes, and the students are the pigeons. Let me know, guys, if there is any question, any doubt. Okay, so let's move forward. Let's move to the next question. Right. Okay. Yeah, we have solved this. Let's just try this question. A bag contains 10 red marbles, 10 white marbles, and 10 blue marbles. What is the minimum number of marbles you have to choose from the bag to ensure that we get 4 marbles of the same color? So that means for at least one color, we get 4 marbles of the same color. How would you find out? Could you please try this once? Guys, at the end, you have to solve questions. So you just have to try by yourself as well. Then you would be able to solve questions in exam. Okay, let's try it once. They are saying that we have 10 red marbles, 10 white marbles, and 10 blue marbles. Right? So we have to make sure that we get 4 marbles of each color, 4 marbles of same color, right? And we have to find out minimum number of marbles. Because in one case you will say that we'll take 4 marbles each from each of the bag and we'll get 4 marbles of same color, but we cannot do that because we want minimum number of marbles. So what you can do here is, if you will take 3 marbles from this bag, 3 marbles from this bag, 3 marbles from this bag, that means I'm taking the worst condition, that I'm not getting 4 marbles from any of the bag, any of the same color. So if I'll take 3 marbles from each of the bag, each of the color, and add one more marble, add one more marble. Now this marble can be red, then we'll have 4 marbles of red color. If this marble is of white, then we have 4 marbles of white color. If this marble is of blue color, then we have 4 marbles of blue color, right? So you have to choose randomly from the bag to ensure that we get 4 marbles of each color, right? Just a minute. 4 marbles of same color. Okay. Yeah. So we have to take 3 plus 3 plus 3 plus 1. That means 10 marbles. We have to pick 10 marbles so that we can make sure that we have 4 marbles of same color. What is the minimum number of marbles you have to choose randomly? Ha. Yeah, that is correct. Right. So now you will say that there might be a possibility that we'll get all the 10 marbles of one color. Right. That would be confusion. But we want 4 marbles of one color. We don't care that it is 4 marbles of red color, 5 marbles, or 6 marbles, or all of red color. If we are getting 4 marbles of same color, then we are done. So that means we have to pick 3 plus 3 plus 3 plus 1. That means 10 marbles from the bag, and we can make sure that we have 4 marbles of same color, and that is the minimum I can do. I cannot decrease the number of balls, number of marbles, and say that I'll make sure that we have 4 marbles of same color. Right? That is pigeonhole principle. I hope this is clear to everybody. Just let me know if there is any question. Guys, if there is any question, please ask. Otherwise, let's solve the next question. Just try this one. How many cards must be selected from a standard back deck of 52 cards to guarantee that at least 3 cards of same suit? Again, the same question as the previous one. How many cards must be selected from a standard deck of 52 cards to guarantee that at least 3 cards of same suit chosen? So we know that we have 4 suits in a card, right? So we have 4 suits in a deck, right? We have 4 suits in a deck, and each suit has 13 cards. Now I have to make sure that at least 3 cards of same suit chosen. So again, if I have to make sure 3 cards of same suit chosen, what would I do? I'll pick two cards from each of the one and add one more card. That would help me to make sure that would make sure 3 cards of at least 3 cards of same suit chosen. So that means in total I have to pick 9 cards so that I can make sure that at least we have 3 cards of same suit. Right. And now you cannot write 10, 12, 13 because they are saying that how many cards must be selected. Right. So these number of cards should be selected. Less than that doesn't work. Greater than that it would work. But we want minimum number of cards. Right. So let me know if there is any confusion. Okay. So this is next question. This is the last question, and you have to try it by yourself, and just let me know the answer for this question in the next class, which will be tomorrow. And if there is any confusion, you can post that in the chat comment section later on this session, after this session as well. And also guys, we are going to complete probability and statistics in these during these lectures, and I'll make sure that you do not have to go anywhere else, and you will complete your syllabus, and you would be able to solve each of the question in your gate exam from probability and statistics. And also in future we are going to get our classes started for calculus and also linear algebra, so that all the mathematics, and further in future we will work on machine learning as well. Right. And also guys, if you are looking for a course, we have launched our course for gate data science as well, in which we have recorded sessions so that you can study at your own pace, and also we have hybrid sessions so that you can interact with our session as mentors as well during your weekly live lectures. And in that course you will get live doubt support and e-study material, and all those things you will get. So if you want a course in which where you get a comprehensive course in which we have everything, right, from mathematics to machine learning and also programming to your artificial intelligence, if you want all these things, you can get in that course. So you will get the link on in the description, or otherwise you will write down on Google Geeks for Geeks Gate Data Science. You will get to the page where we have listed our course, and you can check by yourself. So that would help you in your preparation, because we want your best, so that in very minimum prices we have given you the course so that you can prepare for that. And because you have 5 months left, you do not have to delay in getting the course. And also we are having a sale, so you will get a 30% discount as well for this time, and you can get that course. Okay, so if there is any question, any confusion, you can post that in the comment section. So thank you. That's all from my side.